123 factorial in base system 10. If I do it in base system 21, which is 21, how many number of trailing zeros are present? How many number of trailing zeros are present for this number? This is nothing but number of zeros at the end. Number of zeros at the end. Number of zeros at the end for base system K is highest power of that base system. So this is nothing but highest power of 21 in 123 factorial. 21 is nothing but 3 into say 7. So 123. 3 will be 341. This will be 313. These 3 4s are and it is 1s are. Similarly for 7. 7 1s are 53. 7 7s are. It is 7 2s are. So 123 factorial is nothing but, if I add all these values, 41 plus 13, 54, 58, 59. So 3 power 59 into 7 power 19 into K. I want for 21. 3 into 7 power 19 into 3 power 40 into K. Number of zeros at the end, which is nothing but 19. Number of zeros at the end, which is nothing but 19. I hope it is clear. Praveen, mobile disko. Right, now you can ask me any doubts in this topic. Number of trailing zeros, basics are over. Now I will increase the level of difficulty. Highest power of 21. 21 is 3 into 7. Just to do it for 7, that is enough. Do it for 7, that is enough. Number of trailing zeros. Number of trailing zeros for base system K is nothing but the highest power of K in base system 10. Idea clear? Idea clear? Rambabu, nee phone ivu, din charging ledu. Idea clear? Kindly reply it in the live chat. Reply it in the live chat. Any doubts till now? Number of trailing zeros is nothing but the highest power of 5 in base system 10. What if another base system is given? How to solve? Everything clear? I hope there are no echo issues. You got any technical issues? Kindly reply it in the live chat. Kindly reply it in the live chat. I hope it is clear. Now 123 factorial. Idea clear? So any doubts, please you can ask me. Right? Explain 2 power 3. Priya says, explain 2 power 3 base number of trailing zeros in base system 2. Now we will take up a question, Priya, for you. Right? So let me take up a question. Suppose if it is 60 factorial in a base system 10. If I translate into, she asked 8. How many number of trailing zeros are there in a base system 8? Number of trailing zeros in a base system 8. Number of trailing zeros in a base system 8. So this is nothing but, Priya, for you. This is nothing but highest power of 8 in 60 factorial. 8 is nothing but 2 cube. So 60 factorial is 2 30s are, 2 15s are, 2 7s are, 2 3s are, and 2 1s are. So 60 factorial is nothing but 45, 52, 55, 56. So this is 2 power 56 into K. I want for 2 power 3. 2 power 3 power 18 into 2 square into K. So answer for this question is 18. I hope it is clear. Everybody kindly reply it in the live chat if this concept is clear to you. Is this concept clear to you? Is this concept clear to you? I want everybody to reply it in the live chat, then we will do some exercise problems. Exercise problems. Praveen, some exercise problems which we will solve once everybody says it is clear. Mahesh says it is clear. Anup says good, right? Keep this charging. Kindly reply it in the live chat so that we can go ahead with problems. Any doubts? Any doubts? Highest power of 8 in 60 factorial. Idea clear, right? Now, we will solve few exercise related problems. Now see, first one, find the number of trailing zeros for 100 factorial. For factorial based problems, number of trailing zeros is nothing but the highest power of 5. So directly divide by 5. 5 20s are and 5 4s are. 20 plus 4. Answer is nothing but 24. Answer is 24, which is nothing but number of trailing zeros. Number of trailing zeros for n factorial. For n factorial is always highest power of 5. Is always highest power of 5 in n factorial. Only for factorial based problems. Only for factorial based problems this concept is directly applicable. Only do it for power of 5. Sometimes it will go for a toss if the factorial some changes are done. What is that one? We will see. Number of trailing zeros for 100 factorial is highest power of 5. Answer is 24. Second question. Read the question. Find the number of trailing zeros for 150 factorial plus 200 factorial. 150 factorial plus 200 factorial. Right? Now see here. 150 factorial. 200 factorial is written as 200 into 199 and so on up to 150 factorial. So 150 factorial, if I take common, these 1 plus 200 into 199 and so on. This is nothing but divisible by 5. Divisible by 5 plus 1. That means this number is not divisible by 5. This number is not divisible by 5. So highest power of 5 will not come in this number. So answer is 530s are 5 6 are 5 1s are 30 plus 6 plus 1. Answer for this question is 37. Answer for this question is 37. Priya says, sir, in previous problem we discussed the same problem. 8 in base number 10. Number of trailing zeros for base 2. It is 3. How, sir? Right? Answer is 2. I am not clear with your question, Priya. Kindly WhatsApp your question to our official number which is there on the screen. Kindly WhatsApp it so that I will understand. Prashant says, for method 2, 100 factorial, it is different. 100 factorial, it is different. It is not different. It is the same number. Sohail says, if the given prime number has base system 11 and higher, then the same process. Yes, it is the same process. Let us go back. Suppose for Sohail, it is 120 factorial in base system 10. If I convert into base system 11, so this is nothing but the highest power of 11. Highest power of 11 in base system 120. In base system 120. It is the same thing, right? Prashant, I am not clear with your statement, so I will not be able to take up your doubt. If you can specify it clearly, I will understand. Otherwise, WhatsApp. Right? WhatsApp your entire explanation. I hope the answer is 37. Now, third question. Find the number of trailing zeros for 1 followed by 4 zeros. 10 power 4, power 50 into 10 square, power 30. So, this is nothing but 10 power 200 into 10 power 60, which is nothing but 10 power 260. 10 power 1 will have 1 0 at the end. 10 square will have 2 zeros at the end. 10 power 260 will have 260 zeros at the end. 260 zeros at the end, or in other words, it will have 260 trailing zeros. It will have 260 trailing zeros. I hope the idea is clear. 10 power 4 power 50 into 10 square power 30, 10 power 200 into 10 power 60, 10 power 200 into 10 power 60 is 10 power 260. So answer is 260 zeros at the end. Another question. Slowly I am increasing the level of difficulty. Listen carefully, sir. 20 into 30 into 40 till 100. This is nothing but 10 into 2. This is 10 into 3. Next it is 10 into 4. And it goes on up to 10 into 10. 10 into 10. 10 is multiplied. From 2 to 10, there are total 9 numbers are there. 2, 3, 4, 5, 6, 7, 8, 9, 10. Total there are 9 numbers are there. So it is 10 power 9 into 2 into 3 into 4 and so on up to 10. So this will become 10 power 9 into, this is 10 factorial. This is 10 factorial. Am I right? So 10 factorial is nothing but 2 5s are 10, 2 2s are 4, 2 1s are 1. 5 plus 2 plus 1 is 8. So this is nothing but 10 power 9 into 2 power 8 into 5 square into some other prime bases. So this is nothing but 10 power 9 into 10 square into 2 into 5. 2 power 6 into k. So answer for this question is 11. Answer for this question is 11. I hope the idea is clear. Please do not say the answers in the live chat. I am not asking you to say the answer. If you got the answer, keep it with you, because there are certain questions where you will do a mistake and you will miss out. Why there is a mistake? You have done it because you have missed out that explanation. Kindly clear, right? Kindly clear. It is into 90 is missing, sir. Please add 90. Into 90. 90 is missing in the question. It's a typing mistake. Please add 90 to it. It is 90. In hurry, my team members might have missed it out. 90. It is into 90. Into 90. Please add it. Balaji, yes, 90 is missing. Please add it out. Right? Next one. 10 power 9 into 2 into 3 into 4 till 10. 10 power 9 into 10 factorial. Next one. Another question. Find the number of trailing zeros. Now before this question, yes, let us solve this question. See here. If n factorial ends with 13 trailing zeros, what is the possible value of n? Then we'll solve the previous question, because this we did it. If n factorial ends with x zeros, if n factorial ends with x zeros, this is nothing but n is greater than 4x. We already did this condition. So this is nothing but n is greater than 52. What is the multiple of 5 just greater than 52? 5 11s are 55. 5 2s are 10. 11 plus 2 is 13. So what are all the values you will get? 55 you will get, 56, 57, 58, 59. Totally 5 values will have 13 trailing zeros. How many values n can take? 5 values n can take. 5 values n can take. 5 11s are, 5 2s are, 11 plus, right? 5 11s are, n is greater than 52. 11 plus 2 is 13. That is the question. This concept you should know it. N factorial ends with x zeros. So n is greater than 4x. So n is greater than 4x. Idea is clear? Next one. N factorial ends with x zeros. If n is n factorial is ending with x zeros, what is the relationship between n and x? The relationship is n is greater than 4x. n is greater than 96. What is the multiple of 5? Just greater than 96. 100. 5 20s are 5 4s are 20 plus 4 is 24. So 100 I will get, 101 I will get, 102, 103 and 104. Answer for this question is again 5 values. Right now I think it should be very clear to you how to find out the values of n. If the number of zeros at the end is given, if the number of zeros at end is given, the relationship is n is greater than 4x. Next one, another beautiful question. N factorial never ends with dash number of zeros. N factorial never ends with dash number of zeros. Suppose if it ends with 5, if it ends with 5, if it ends with 5, n is greater than 4x, 4 into 5, n is greater than 20. What is the multiple of 5 greater than 20? 25. 5 5s are 25, 5 1s are 5, 5 plus 1 is 6. It ends with 6, never ends with 6 is over. What is the next multiple of 5? 30, 5 6s are 30, 5 1s are 5. What is 6 plus 1? 7. It ends with 7 zeros. If it is 35, 5 7s are 5 1s are. What is 7 plus 1? 8. It never ends with 5 zeros. I hope the idea is clear. If I take the option number 1, assume that if it ends with 5 and check whether my assumption is right or wrong. N is greater than 4 into 5, n greater than 20. So what is the multiple of 5 greater than 20? 25. 5 5s are 5 1s are. 5 plus 1 is 6. 6 I am getting. 7 I am getting. 8 I am getting. So 5 I am not getting. So answer for this question is 5. I hope the idea is clear. Next question. N factorial ends with 20 zeros. N factorial ends with 20 zeros. 20 zeros in base 21, which is 7 into 3. Now see here, similarity. Once you get the similarity, this question is very easy for you. If n factorial ends with 15 zeros in base system 10, in base system 10 is 2 into 5. First I took the highest power 5. This got n is greater than 4x. From where you got 4? 4 is 1 less than the highest factor of 10. 1 less than the highest factor of 10. Similarly, this is nothing but 21. Highest is 7. So this answer is n is greater than 6x. I hope it is clear. Beautiful conclusion, sir. If it is in a base system 10, 10 is 2 into 5. Highest is 5. So this will be n is greater than 4x. n is greater than 4x. If it is 7, it will be n is greater than 6x. n is greater than 120. What is here? I took the multiple of 5 just greater than the number. Here I will take the multiple of 7 just greater than that number. So 126. 7 1s are 7. 7 8s are 56. 7 2s are 14. What is 18 plus 2? 20. So from 126 till the next multiple I will get the answer. Till 132. 126 till 132. Answer is how many values it can take? 7 values it can take. Right? I hope the idea is clear to you. I hope the idea is you don't need to convert it. N factorial ends with 15 zeros in base system 10. In base system 10 is 2 into 5. Because it is 2 into 5, powers of 5 are smaller than the powers of 2. So what I did it? How I got these 4 by x? I did it as x is less than n by 5, n by 5 square, and so on up to infinite. That is where I did it. X is less than n by 5. Here in base system 21, it is 7 means what will be the equation? X is less than n by 7, x is less than n by 7 square, n by 7 cube, and so on up to infinite. If I solve that equation, I will get n is greater than 6. N is greater than 6. 6 into 20 is 120. N is greater than 120. What is the multiple of 7 greater than 120? 126. 7 18s are 7 2s are. 18 plus 2 is 20. So in base system 10, I took the multiples of 5 and remaining all 5 values. Here multiple of 7. 126, 127 and so on up to 132. I hope the idea is clear. I hope the idea is clear. One more question which we will solve. Please write down, sir. Please write down. N factorial. N factorial. I hope the idea is clear. It is in base system 14. It is in base system 14. Right, actually it is 1,4, but I am calling it as an 14 because I will eventually convert into base system 10. 14 is nothing but 2 into 7. Highest is 7. So it is nothing but n is greater than 6x. N is greater than 120. So this is nothing but, if I take it as 15 zeros, if I take it as 15 zeros, let me take a different value. If I take it as 15 zeros, so this will become n is greater than 90. What is the multiple of 7 just greater than 90? So it is 7 13s are 91, 7 1s are 7, 13 plus 1 is 14 I got, but I want 15. What is the next multiple of 7? Which is 98. 7 14s are, 7 2s are, 14 plus 2 16. I got 14 here, I got 16 here. Why? Because 98 is 49 into 2. There is a direct jump from 14 to 16. 15 will not be possible. No value of n exists. No value of n exists. I hope the idea is clear. No value of n exists. What I am doing? 20 is replaced by 15. 21 is replaced by 14. 14 is 2 into 7. 2 into 5 means n greater than 4x. It is n greater than 6x. N greater than 6 into 15, 90. N greater than 90. What is the multiple of 7 greater than 90? 91. 7 13s are, 7 1s are. 13 plus 1 is 14. Next, for what is the next multiple of 7? 98. 14 plus 2, 16. 14 became 16. 15 is not possible. No value of n exists. No value of n exists. I hope the idea is clear. In base system, other ones. Now let us solve one question that we did not solve. What is this question? Find the number of trailing zeros for 2016 factorial. 2016, if I divide by 5, 5 403s are, remainder 1, 5 80s are, 5 16s are, 5 3s are, 5 3s are. Similarly for 1008, it will be 5 201s are, 5 40s are, 5 8s are, and it is 5 1s are. 5 1s are. So 2016 factorial, how many I will get? These nothing but 80 plus 16, 96 and 99. 96, 99, 502. So this is 5 power 502 into K1, remaining all prime numbers, divided by 1008 factorial whole square. So these nothing but, how much I will get? 241, 250. 250. So these nothing but, this is nothing but 2 power 250. Please check the calculation. 16, 19, 99, 502. That is clear. 949, 50 into 2 whole square. Sorry, it is 2, not 2, it is 5 power. It is 5 power 250 whole square. So these are nothing but 252s are 500. So answer is nothing but 5 square. Number of zeros at the end for this expansion is 2. I hope it is clear. First I did it for 2016. 5 403s are, 5 80s are, 5 16s are, 5 3s are. 96, 99. So which is 502. 5 power 502. 1080s 201. 540s are, 58s are, 51s are. 49, 50. 5 power 250 into K2 whole square. 252s are 500. Answer is 5 square. Answer is 5 square. Answer is 5 square. I hope it is clear. I made a small mistake. Instead of 5 power 250, I took it as 2 power 250. Please make a note of it. Idea is clear now. Idea is clear, right? Now we will solve few more questions. Still here, is it clear to you? Kindly reply in the live chat if till now trailing zeros. Foundation problems and exercise problems. Foundation problems and exercise problems. Is it clear to you? Kindly reply it in the live chat. Kindly reply it in the live chat if everything is clear to you. Kindly reply. Reply it in the live chat. Reply in the live chat if everything is clear to you. Right? Ambika, sir, why 150 factorial plus 2 factorial? We take common. No, we cannot take common. It is plus sign, Ambika, here. 150 factorial plus 200 factorial. If I take common, these 150 factorial, these 1 plus 200 into 199 and so on. This is divisible by 5. Any number divisible by 5 plus 1, that will be not in factorial, that will be 5k plus 1. Any 5k plus 1, any number which is of the form 5k plus 1, 5k plus 1, it is not factorial, Ambika. It is just a natural number. 6 is 5 into 1 plus 1. It will not have any power of 5. 11 is 5 into 2 plus 1. It will not have any power. I hope, Ambika, it is clear to you. Find the number of trailing zeros. Now we will solve some more questions. Some more questions. 1 minute, sir. Now please solve these questions. Then slowly the same model which we discussed. Number of zeros which are not possible at the end. Do it with one example, you will understand. If I take option 1, n is greater than 4x, n greater than 76. 76 is, next multiple is 5. 5 16s are 80. 5 3s are 15. 19 is possible. Option 2. Option 2. It is 28. n is greater than 4x. n is greater than 4x, which is 112. What is the multiple of 5 greater than 112? 115. So it is 5 23s are, and it is 5 4s are. 23 plus 4 is 27. Next multiple, 5 24s are, and 5 4s are. 24 plus 4 is 28. This is possible. Option 2 is also possible. Option 3. n is greater than 4x. n is greater than 144. What is the multiple of 5 greater than 144? 5 29s are, 5 5s are, 5 1s are. 35. Next it is 150. 150 is 5 30s are, 5 6s are, 5 1s are. 37. Directly from 35 to 37 there will be a jump. Why? Because 150 is 25 into 6. So 36 is not possible. That means if you check it out, 47 it is possible. 47 it is possible. I hope the idea is clear. 5 16s are, 5 3s are. Right, 16 plus 3, 19. First option is possible. Second option, 28 is also possible. Third option, it is not possible. So answer for this question is 47. I hope this is clear. Trailing zeros, advanced level. Next one.